Hello student, my name is Drashti Mori. I am professor at New LJ Institute of Engineering and Technology. In this video lecture, we are going to cover a linked list and it is a part 2. And this topic is from the data structure subject. In this video lecture, we are going to cover traversal, then after insertion and then after one deletion operation. When I say traversal, I have to visit each and every node. And for that, I require some temporary pointer which can lead me to the each and every node. For that, first node location I have to get, and that would be at start pointer. So start pointer will give me the address of my first node. For demonstration purpose, this is the diagram where temp is one pointer which is pointing to my node 1 right now. Okay. Now what will happen if I want to get the value from first node? What can I do? I will write temp info. Yes or no? So whatever here, if some information is here, I will get their information through this step. Then after I want to read 20. So for traversal, what step I need to do? I need to update my pointer. For updation, I use is equal to temp link. So every time where I am, I just have this way I can visit each and every node, and whatever operation I need to perform, I will do in my do part. Fine? Am I clear? And when should I exit? When I reach to the last node. Fine. Now let me give you one more operation, that is insertion. When I say insertion means in existing linked list I have to add some new node. For that I require available space, and that available space would be pointed by one pointer, and that is avail. In our case 102, 104, 7 and 8 all are free space. So this free space need to be linked by each and every node, right? So 102 is my first free space. It would pointing to the next free space. Likewise, this is a 108 is the last free space and it will point to the null. So we get to know that 108 is the last free available space. So if some person add any value at 102, 104, 107 and 108, it means all the free space would be occupied by some node. So in that scenario, avail will become null because it have nothing to point. No free space is available and you cannot add something in this linked list. So each and every time whenever you want to create some new node, check if there is a free space to create one new node or not. So this would be every time your first step whenever you want to insert any new node. Fine. And that condition is known as an underflow condition. So write down underflow message on your screen and return from your algo. Fine. And if it is not there, what would you do? You have to create one new pointer which will point to the location where we are going to create a new node with the value of, in our case, we want to create a new node with the value of asterisk sign. Fine. So where should I point? Which location should I write asterisk? As my second step says, new would be get their value from the avail. Avail pointing to 102. So new would be 102. So whatever I am going to cover, whatever I am going to create, it would be at 102 location. Fine. So now 102 will not be a free space. It would be occupied by new node. So now we want to deduct that node from the availability stack. How can I deduct? By changing the pointer value from the avail. If I change the value of avail to 104, why? Because 104, because now next available free space would be at 104. So I update the value of avail by 104, and that would be my third step, that avail get their value from the link avail. Fine. Now what is the fourth step? Fourth step is to initialize our new node. Initialize means you also have to update your info part as well as link part. For updation of info part, what is the new value you want to add? That will be stored in variable x. So in our case, asterisk side would be here, and as it is a last node, what was the problem statement? It says you have to create a new node and add that created new node at the last, and every time last node have the pointer null, so this would be updated with the value null. This would be the fourth point. Is this clear? Now what was the fifth step? Now check if my linked list is null or not. When I say null means, if first is having pointing to value null means you don't have any node to point. And what do you mean by that? If first don't have any point to link, it means your linked list is empty. You don't have anything in your linked list. In that case, what would be the linked list? New only. That newly created node is the only node in your linked list. So what should I return? What should I return? I just return new, because it is the only node which I have to return. Fine. And if it is not a case, your linked list is not empty, in that case, what you can do? You have to traverse. Yes, you have to traverse till the end. For that you require one extra pointer. Yes, that extra pointer is saved, and that traversal start with which location? From the start. Start have value 103. Yes, so 103 would be the first value where you can start, and then after you have to repeat the process of traversal till you reach the value null. Okay, so 103 is my value. Then after, what will be the next value? Look, what is this? 106. So link of save is, what is the link of save? Save is 103. Then link of save is 106. So newly updated value of save is 106. Now 106 pointing to which node? 105. So your new value would become 105. Now check. Did I have the link value of 105 null or not? In our case, it is null. So this condition is wrong. So I need to be come out of this loop. Yes or no? So this loop will give me the last node of your linked list. Yes. Right now it is giving me the location 105. So it is the last node of my linked list. Fine. Now what you can do? You add the newly created node at the end of your M. This is your M 105, and this is your new node having value hashtag. And what was the location? 102. Yes. So now this will point to 102. How can you do this operation? By link of save. Link of save means 105 link means this part would be updated with your address of new. New have value 102. Okay. So this M will now point to the hash sign. Yes. And it pointing to what? 102 have link part null. Yes or no? So now it is the complete linked list with the end of. So what you can read, if I want to traverse and read all the step, it is DJM hash sign. Okay. So this is the final linked list. And now what you can return? You always return your first node address. Where is my first node address? In this case, what is my first node address? What is the first node? This. This is my pointer to the first node. So I will return the first. Fine. This is the way we can insert some new node at the ending. Okay. Now let me see one more example of deletion. In the deletion, what you can do? First of all, question itself have some specific node position that I want to delete 104, 105 memory location can be given, or you can be given the info part. In our case, it says J would be deleted. J is at which location? 106, right? So avail is there, first is there. Now X have the value 106. In algo part, it is able to give you the memory location. But in a program, you are not able to find the exact memory location. At that time, what they give you the info part. But in algo part here, X are being given. X have the memory location of your node, which are need to be deleted. Fine. Now, what was the first step when I say deletion? If you want to delete something, check. Did I have any node in my linked list or not? If I don't have any node, then it is, if first is it equal to pointing to the null, it means it is empty string. Yes or no? If null is pointing to, if first is pointing to a null, it means your linked list is empty. You don't have to traverse to look after your X node. आपको X node ढूंढना ही नहीं है. In that case, what you can do? You just return from the first step. Yes. Then what is the second step? For traversal, you require some temporary variable, and then I require to perform some step. But make sure whenever you want to delete some node, you require to store the address of your previous. Consider this is my node X, and if I want to delete this node, I require to store the address of this node as well, because I need to change the link part of the previous, let me call you predecessor node. Okay, now this is the predecessor node, so predecessor node should point to my next node. Then after I can say X has been deleted. If I don't modify this link, linked list would not be perform the deletion operation. Yes, for this I require to maintain the predecessor pointer. Fine. So here temp is there, and one more pointer I require, that is predecessor. Okay, the predecessor is get their value from the temp. Now in our case, what is temp? Temp have the value from first. What will first have? First have 103. So predecessor also have value 103. Now this condition is true or false? This condition is, right now we don't reach the location 106. So this condition is true. 103 is not equal to 106. So this condition is true, as well as our link part is also not have null. So this both condition are true. So I need to do the both the operation. This both operation are under the while loop. So what is the fifth step? It says you have to modify your temp. So what would be the new temp value? It would be 106, because 103 is linking to 106. Fine or not? Now check. These two conditions are same for same or not. In our case, we are at 106 and X is also 106. So no need to traverse, because first condition become false. Yes. So I just jump out of this loop and I jump to the sixth step. What would be the sixth step? Sixth step would be, if I reach the last node and I didn't get the what I am looking for, it means my linked list don't have that memory address. Okay, so in that case you can write the message node is not found and simply return. But in our case we reach the right location, right? So what you can do, check if the location is same as first or not. If it is same as first, then I require to modify the first pointer. And what would be the modify value of first? It is been link of first, because our next node become what would be the my first node in this case of deletion of first node? Node 2. And node 2 would be addressed by link first. So this way we can modify the first value. Fine. Now what would be the next step? In our case, as it is not a first node, what you can do? We need to update the predecessor link. What do you mean by predecessor link? In our case, predecessor is 103. So 103 memory location have to modify their link value with the help of link X. 106 link part is 105. Yes. So 105 value need to be changed or been updated in predecessor link part. So what is this? Predecessor is 103 and the link part is here. So now this value is not more 106, it would be 105. Fine or not? This modification I need to perform. And then what can I do? I just free the memory space of that 106. Okay, because I don't require that address. And how can I free the space? For free the space, I need to add that node to the availability stack. When I say I need to add that in a availability stack means you have created this node as the first node of your availability stack. And it will get the value 102. Fine. And now avail is 106 because this is the first free space. Fine. And we will return from this step. This way we can free the memory space and add that free space to the availability stack. Now try to solve these two examples. First say you have to add the node after B. So what you can do in this first example, in the first example you have to traverse till you reach the node which have value B, right or not? For traversal you use the temp pointer, or you can use save pointer, or you can traverse in a list and stop whenever you find value B. And then after what can you do? As here new node would be created at position 102. So 102 would have the value C and it will point to where? As it is not a last node, you have to check that B is pointing to what? Need to be created with the help of new available space. And now next free available space is 104. So modify the avail. Then after what was the next step? You have to change the link part of your newly created node. Now you have to check that what is the position where you have to point. It is 105. So why it is 105? Because B is pointing to 105. So C should now point to the 105 and this is now 102 because the address where C is been added is 102. Fine. Now your linked list would be A, B, C or D. Now the question is you have to remove the C. When I say remove the C means now again you have to traverse and check where is your C location. In our case it is at 102. Fine. So here you have to write the step to perform example 1 and example 2. I hope you are able to perform the step of this two example.
Thank you. Here we end our video lecture.